Okay, if I go into presentation mode, does it look good? Nice. Let's minimize this.
Can't live stream it, but that's fine.
Yeah, just record it. It'll be good.
Yeah, you're good to go.
Okay, cool. Okay, so yeah, I put this presentation together to kind of give everyone just a brief overview of NEAR and try to go over some like core technical concepts just so everyone is ready to go. So like the idea behind it is that it's just super simple to use. And like the idea is like, for a hackathon like this, the ideal scenario is that, people are gravitated towards the protocol because of the ease of onboarding. So as I just mentioned, this is just a brief introduction to NEAR. My name is Ken Miyachi. I'm a senior software engineer at the NEAR Foundation. Based out of Austin, we have a lot of great kind of NEAR events throughout Austin that are pretty fun. So definitely come check it out. And I'll try to get you guys the link after the presentation. So the agenda, this presentation has like a blockchain basics, then like kind of NEAR concepts, building upon that, like why this is important, then some just basic examples, both with our JavaScript SDK and our Rust SDK. And then at the end, yeah, a little resource dump. So I want this kind of to be interactive. I think that's, when they're better. So like definitely feel free to just be like, I don't know, ping questions, or if anyone online has questions, like interrupt. And I always think like it's the best way for these things to go. So my current plan is I was going to skip over these blockchain kind of foundations. I feel like everyone knows what, do you think it would be helpful to go over this stuff? Like what a hash function is? Okay, cool. Okay, so, right. Hashing is a key kind of technical concept in blockchain in general and just in general cryptography. So what is a hash function? A hash function is something just a function, just like any other function, but it takes an arbitrary size data, whatever it may be. It can be different data types, and then it outputs like a fixed sized data structure essentially. So like, right, the example that is used in here, SHA-256 is a very popular like hash function, hashing algorithm. Hello. And it outputs a fixed 32 byte string, or 32 bytes of memory. And another thing about it is that it's called a one-way function. So the idea is that you couldn't go from this 2CF ... back to hello. You need this function. It only goes one way. It only goes from hello to that encoded string, not the other way around, which has a bunch of security principles. And it's often used, in fingerprinting of data. It's used for identification a lot of the times. So there's a lot of just core concepts in blockchain and then just cryptography that it's really important for. So going into kind of the cryptography of a blockchain, there's two main types of cryptography that people often talk about. The first is symmetric key cryptography, and you can think of that, I almost think of that as like a password. You use it both to encrypt and decrypt your file. If you have like notes on your iPhone, or you have like an encrypted PDF, you oftentimes you type in the password to protect it, and you give someone the same password to then decrypt it, and so that they can view it. Asymmetric key cryptography, often called public key cryptography as well, is when you have different keys for encryption and decryption. And there's different kind of flows, different workflows, different processes that happen when you're using asymmetric key cryptography. But oftentimes you have a public key that's verifying identity, etc., and then you have a private key that's actually decrypting, that stays with the user and that is not shared kind of throughout the network. So what is a distributed system? This is I think like terminology, sometimes blockchain can be the terminology used can be like overwhelming, and it can be a little too much. But at the most core level, a distributed system is essentially just a computer like a single system that talks to computers on different networks, you know. So it's actually like, I would say most of our computing resources nowadays are essentially distributed systems. And yeah, I like this, lots of computers talking to each other is like, I don't know, the core of how you can think about it. What makes this unique or a little more difficult than like just like running any system on, you know, your laptop or any like hardware is that you need to have synchronization and agreement on data processing, etc. And it opens up, you know, the possibility for malicious actors or kind of just mistakes to happen throughout the network, because you need the synchronization and agreement throughout this distributed system in order for an application or program to properly function. So trustlessness, you know, another word that's thrown around, I think maybe a little too much. But the concept around trustless, like when someone says something is trustless, it means that you just don't have to trust, or you don't have to have a third party authority that is like governing whatever it may be that you're doing. Like, I don't know, the common thing is like a bank account. For you guys, like think about like University of Texas is controlling your, like, you know, whether or not you graduate or not, and they're going to be the authoritative figure of like, okay, did you graduate? Do you have a diploma or do you not? And in a trustless system, you don't need that. And the idea, right, is that you're replacing this third-party entity oftentimes with software, with an automated system. And so what you are trusting is the system as opposed to an entity that's oftentimes like a human or like a, so yeah, in terms of is anything ever trustless, like it's a perception thing like a lot of things, but there are a lot of systems that you don't like, that you just don't need like a central third party to do anything for. Yeah, but like, okay, let's say like what the easy one is Bitcoin, of financial. If like you have a Bitcoin address and I have a Bitcoin address, we don't need Visa, we don't need Chase, we don't need anything. You're trusting this network, you're trusting the software to do it. And so like, I mean, at the end of the day, we're humans, but you would have to, for you to do something malicious, you would have to like you would have to do something malicious against that network, the Bitcoin network, as opposed to like, I don't know, hacking the Visa or JP Morgan Chase bank account.
I guess on the application level.
On the application level, yeah. So like oftentimes, I would say oftentimes there's a huge benefit of having like, you know, a trusted third party to do things like you just talk, like there was just a presentation about forks and you know, decision making that needs to be made. There's a lot of, and like Spotify, it's like, hey, there's a lot of value in saying like, hey, like you can't be an artist on our platform if you're like a SoundCloud rapper. Like, we're not going to allow that. You need to prove something, and like we need to have some validation and verification to prove that you're legitimate or not. So I think a lot of times that is the best case. And I think as these applications become more mature, a lot of it is becoming what you're saying. It's gravitating towards, it can't be fully trustless. This whole system itself can't be fully trustless. There's going to be some, you know, centralization involved at some point for like an application to be seamless, have the user experience that you want it to have, etc. But at the same time, I do think there's microservices within like maybe a full ecosystem of applications that are just applications itself that can be trustless. An example that we have something called the Rainbow Bridge, which is like basically the connection between Ethereum, Near, and Aurora. And the idea is that that's a trustless network, like nothing. And there was like a recent, for instance, like we have sometimes when there's a hack or there's something that goes wrong, there's third-party intervention, which you could argue, I think that's actually on the lines of like, it's not a trustless system anymore. Yeah, you're like convincing the node validators to you know, agree on something that like wasn't the core software what I was doing. But there was a attempted hack on the Rainbow Bridge, and it was basically he just like the guy ended up, the software helped mitigate the solution. You know, he wasn't able to do what he wanted to do, and nothing needed to be, didn't need to be like any third-party intervention behind that. And I think I'm not sure if it still holds, but what they were touting it as when it was first coming out was like the first trustless bridge. Like oftentimes you need, you have a smart contract running the bridge, but you usually have some sort of like safety measures in check, and this trustless bridge. Okay, blockchain. So really how I think about this, the core data structure behind a blockchain is a linked list. If you're familiar with like, I don't know, core data structures. And then when you think about that linked list is kind of comprising through Merkle trees a ledger, which is essentially a distributed, you know, data storage system. And it can kind of be whatever you want. You can store different types of data. It can be structured, unstructured, anything. But at the most basic level, you can kind of think of it as a spreadsheet or a state machine. You have transactions, and then you have like a group of transactions usually comprises a block, and that's kind of, they're chained together through this linked list, and that's where you get blockchain. And something that also makes it unique is, right, when we talked about distributed systems and staying in sync, there's something called, you know, consensus mechanisms or consensus algorithms that are governing the way this distributed system stays in sync. The most popular one, proof of work right now. I think most of the modern ones are some sort of proof of stake, but like the proof of work was definitely kind of an innovative concept when it first came out. So what is a smart contract? I also like this definition. It's an autonomous on-chain actor. So the idea is that it's a, you know, it's a deployed set of software that manages data and can modify, view, perform operations on a specific set of data, and it's deployed logic, like, right, but that's what all computer programs does. The difference here is that when you deploy it to a chain, it's you know, it's there. You can't modify that deployed smart contract. You can do different things for upgradability, but at least that like deployed contract will stay there forever. The advantages is that, right, you can kind of prove all that the transaction happens like cryptographically. A lot of transparency there. That is actually a pros and cons, and it's trustless. Like, what you're trusting is this deployed software to perform the operations. You're not trusting, you know, any individual or entity to do so. The limitations is that it's deterministic, which means that if you pass something in, if you pass the same input in, it has to be deterministically, like, you need to get the same output out. So that's what makes like generating random numbers really difficult on blockchain. Computational speed and memory, right? We have issues with scalability, and that, like, a lot of chains are working on the scalability issue right now with data storage and computation speed. Okay, so I ran through that. Now we're going to go into like near specific stuff. Okay, near. Okay, developer friendly, sharded, proof of stake, layer 1 blockchain. You know, the idea behind it, Near actually started as an AI company, and they wanted to distribute labeling models, and they couldn't find you know, there was an issue with distributing payments throughout the world for like labeling. And so that's how kind of this AI company became a blockchain company. And the idea is for scalability and usability. Those are like the two kind of core concepts. And then on top of that, we're carbon neutral, hopefully trying to get carbon negative soon. But we got audited by a pretty like legitimate, like, I don't know, carbon firm, and they
Was that the CTRI?
let me see, it wasn't CTRI, it was called like, started with a P, I believe. But like they've done like pretty, they've been pretty critical of big tech, because like just like office footprint and South Pole, climate neutral product label from South Pole. Yeah, and they just do like reports. I don't know, they do reports all the time about like carbon footprint, and it's, I mean, it's a difficult, what I would say is like a difficult thing to track. There's a lot of components that go into carbon footprint, so, but they seem pretty robust with their analysis. Okay, so I'll go into this a little bit later about why this is important, but just to go over general topics like near accounts and keys, it's a unique aspect of the near blockchain. Generally, an account ID doesn't equal a public key, which is, I would say on Ethereum, that's kind of the case. Like your wallet address is what you give out as your public key so that people can send you ETH and you can do transactions. On Near, you have a human readable address, usually natively. So like mine is like ken.near, right? And you can get your name. And then there's this concept of around sub accounts, which would be, let's say like, utaustin.ken.near, and anything kind of just like as a web domain, you have access to all the sub accounts kind of in that namespace. So xxx.ken.near, I have access to anything in that domain space. Another really interesting thing is that you can have multiple keys for each of your accounts. And so this is interesting because it opens up the concept of like function only keys or kind of not full access keys. In Ethereum, there's only full access keys, but you could have something like a backup key where you give it to your friend or a bank or something like that. And the only thing that they have access to do is recover your account in case you lost your key. So, I mean, I think like over billions of dollars have been lost to just lost keys in crypto. And so hopefully this helps improve that. We like, that's like, I think that's a pretty big barrier of like entering the market. Like that guy who had, he's like trying to go through the trash right now. Yeah, he's trying to go through the trash. But and he's raising money for it because it's like over it's like $100 million. Yeah, it's like a lot of money. So I get him. I understand. But yeah, like ideally that should never happen. That wouldn't happen in a centralized in a banking system. You'd be able to figure it out after you prove your identity. So transactions and sharding. So the really like the unique thing about Near is that we the idea is around our scaling solution is around sharding to get like this really high TPS, and different chains have different thoughts on sharding, but essentially sharding is when both the state and the transaction, the kind of the execution of the logic in the storage gets partitioned into different into different shards, into different pieces, and then gets pieced back together to get stored on chain eventually. And that increases the throughput that the network is allowed to process. It's a difficult technical achievement, but ideally what like our concept or philosophy is that it's probably, I don't know, the most scalable solution to like getting that like, really, really high throughput of transactions. So there's 8 action types that you can perform on the Near network. Think about it as like opcodes. If you're thinking about it like an operating system, you have like add, subtract, in kind of regular operating systems. You have create account, delete account, add key, delete key, deploy contract, function call, transfer, and stake. Most of what you're going to be writing in smart contracts are function calls, right? You deploy, add, and delete keys, create and delete accounts. Transfer and staking is like kind of the core of it, but when you're writing smart contracts, like you're writing functions to get called as a function. So the development platform, the execution environment is WASM VM. Like it's like everything compiles down to WebAssembly. So right now, what we currently support are Rust, JavaScript, Solidity via Aurora. And what you can think of Aurora is it's a EVM. It's a smart contract that is an implementation of the EVM on the Near network. And so what that enables is that you can write Solidity code, deploy it, and execute it via that smart contract. And then we're actively trying to onboard new languages right now. Like I know like a big focus is on Python, and like I know a team is working on Java. So like just trying to really make it as seamless as possible. Like it shouldn't matter what language you should be able to write logic and deploy that as a smart contract. we have two like public like RPC libraries, both in Rust and JavaScript, and then there is a dev console kind of like RPC as a service contract management UI. It's called the Pagoda console, and it's like I don't know. The idea is that it's a great dev tool for yeah, developers to kind of manage everything as opposed to like managing everything on your terminal through the CLI. So I kind of just went over like really, I don't know, the core concepts, but I didn't really go over like why this is important. So with this account model, what it adds is like really this goes to the usability of it, human readable accounts, the access keys where you can recover. But think about like access keys, what if I wanted to give, my friend access to, I don't know, view my like, I don't know, my rent history. I don't know, something like that, right? You can give them specific keys that only have specific permissions based on them. And then those namespaces really allow for like applications to onboard users easier. Like let's say an application is like what, like FIFA.near, and they want to create a bunch of accounts under FIFA.near. It allows them to like onboard users a little easier. The tech stack, yeah. Like I think, right, all these we just made a huge push in the JavaScript TypeScript area. So just trying to get, it's the most popular programming language in the world. So just trying to get users on there. And then the other kind of last piece is like this idea around user gas fees. So developers can pay for the user gas fees. And then there's this concept around where some of the transactional costs are also given back to the developers. So it's like you're incentivized to create and become a developer on Near. And then on the scalability, right? Like Near infinitely scalable with dynamic sharding. So the idea behind dynamic sharding, which is like kind of the end goal of the protocol, is that as transaction throughput increases through the network, more shards get split out so that it's not, it's getting optimized just based on the traffic. You can think of it, if anyone's familiar with like Lambda functions or like serverless applications. That's kind of the concept behind there. So yeah, like approximately 1.5 second block time. So you got finality with 1.5 seconds. You have like what I think 1000x lower gas fees than Ethereum, and then it's asynchronous and non-blocking. So like it's not going to get your transaction won't get stopped if like it is relying on a previous transaction. It will just wait for the promise, and the chain will keep going. So as I said, I kind of just mentioned everything. We just really are trying to prioritize the developer experience. And then on top of that, we have like a grants program that, right, I think it's like really focused on bootstrapping projects for development costs specifically, who don't have like maybe a go-to-market strategy yet or really built out business plan. But the idea is like, okay, this grant program will help the teams bootstrap to get to a point of an MVP where they'll be able to, raise funds and like actually create a killer product. So this is just like a visualization of like a comparison to Ethereum, like, right, this one account, one key piece. If you lose your key, you lose your account. And then if you make a new account, you have to transfer all these assets. Like it's just not, it isn't the most usable. It's simple, but it's not the most usable. So by creating this like one account and having many keys, an option of having key rotation to an increased security, and then also the option to like natively have multi-sig incorporated into the account, like allows for just basically a lot more flexibility and functionality than what's in some other chains. This is kind of the roadmap to this dynamic sharding. So we just finished phase 1, which is chunk only producers. So this like increases the number of validators on the chain, and it introduces this concept around like validating nodes are only validating a specific aspect of the entirety of the process, which is chunks. So in Near, you have transactions which are grouped into chunks, and chunks are grouped into blocks. There's like an extra, I would say there's an extra aggregation step involved in our block generation process. And so this phase 1 is when a set of validators are validating chunks on only a specific shard. Right now, or previously, validators needed to be validating for all shards on the chain. And this opens up for Nightshade when both state and processing will be fully sharded. And it will, like that, at that point, it will eliminate the need for any validators to track all shards. So it will be like, this will be like a really big step in terms of our scalability. It will lower the hardware requirements because all the validators can only focus on one shard versus like needing all the computation power to validate all shards. And then the final phase is this like kind of this dynamic splitting and merging of shards, which I talked about. Like, let's say, this becomes really popular in, I don't know, Western Europe, and you see like a huge traffic spike during the business hours of Western Europe. It's like, okay, well then, there will be more shards generated at that time of the day when it's business hours in Europe, and it will get decreased when it's not. And so the idea behind that is that it's like, it's an optimization of resources, even though it is proof of stake and it's much better than proof of work from an energy efficiency standpoint. Like the idea is to have great resource optimization and also be infinitely scalable, be able to handle this like giant increase in traffic. So like kind of overviewing everything is that like I would say the difference conceptually between some of the other chains than us is that, right, a lot of the L2s are their scaling solution, which creates some fragmentation with both the users and the tokens that are involved in these different kind of protocols or ecosystems. And then it puts the developer in charge of creating the technology stack to handle the scalability. Do I build on Ethereum? Do I build on Polygon? Do I don't know, just go with Solana? Like, there's a lot of design decisions you need to make when you're thinking about it. And like, maybe, your app, you almost for sure know if like your app grows, like you'll face different challenges as you grow. And so the idea is that we're trying to simplify that process where all the kind of the complexity around having to scale is just in one single homogeneous blockchain, where the developer doesn't have to like keep track of that. They just can deploy their contracts and have this value proposition that, yeah, it will scale and will be secure. And then the other like big one is that, right, you don't have to bridge to other environments. Ideally, you can just keep everything on Near. You don't have to like use Polygon to scale and then wait a couple of days to get that back on Ethereum and then finally cash out. Like a variety of different things there that like keeping in one ecosystem, we think maybe has like a lot of benefits. So I'm gonna now just go over briefly, just take like a little dive into these contracts. So this is like, I don't know, this kind of, in my opinion, like this is really great. It highlights how simple this JavaScript SDK makes the smart contract development. You can see that basically this, right, this class has just two basic functions. It's an unordered map of points as the data storage. And this flip coin, all it does is you guess a side. And then depending on if the guess is the same as the outcome, then it'll call simulate coin flip, which is literally just generates a random string, mods it by 2. And if it's right, if it's even, it's heads, if it's odds, it's tails. And then it just adds or subtract points to the player's points based on if you get it right or not. And so this just kind of highlights, I think everyone's really excited about this JavaScript SDK just because of how easy it makes. It lowers the hurdle of entering the space. And then this is like a classic example that is used. I think it's the most popular examples in Near Examples, in the Near Examples repo. But this is just this is a basic like NFT library. So a lot of this is using kind of like Open Zeppelin. There's a couple different standard libraries, but Near Contract Standards, token ID. There's a non-fungible token as well. I believe there's owner as well. So there's a couple like standard smart contracts that you have templates for. And all this does, right, new default with meta and new, these are the initialization functions. And what this does is it initializes the NFT smart contract with the name, symbol, icon, the base URI. If you have, if you're trying to link it to, right, anything on like IPFS or distributed data storage, and then reference and reference hash are like, they're oftentimes hashes or representations of the data that's being stored as the NFT smart contract. So then here, right, what this does, right, it literally, you have a couple getters, it gets the NFT metadata, and then most of it, and then you have the mint, which, all you do is really pass in a token ID, the receiver ID, like who is this NFT going to get minted to, and then the metadata associated with that NFT. So you can think of like, right, the picture and the attributes associated with it. And then that will get sent to, by calling this library self.tokens.mint, this function that is imported from input from non-fungible tokens. If you see it's initialized here, it gets called and the NFT gets minted to the receiver ID. So like I would say the JavaScript SDK is really good to prototype and test out your ideas. The Rust SDK is significantly more mature. So, it has a little more robust documentation, and some of the there's definitely a lot of examples in Rust and a lot of support in Rust. But I think the JavaScript, there's like a really hard push for it, and definitely super excited about some of like the future developments on the JavaScript side. So then, like a really good resource that if you're interested in learning more about Near is this course called Near Certified Developer. So essentially what it is, it's you can sign up for a class. They give you a variety of slides and resources similar to what I just gave you, but much more in depth. And then what you do is essentially you have a capstone project. And the concept is that, you create a smart contract application. You can just call it with the CLI, and then like the most basic form, you could make a UI wrapper around it and have a front end, but not necessary. And then you submit the video via, like you just record it via Loom and submit it. And then if you've met all the criteria of using storage, context and environments, persistent collections and assertions, do some testing, then you're like a Near certified developer. And that is a great way to get introduced to the Near ecosystem. And then there's all these examples of like past projects that people have done and that have been created by the team to help you get started, which are like here, there's like a thank you cardboard. This is a lottery. This is like a neighbor app. And then there's a meme museum, which is like, think about it like a display of NFTs is how it kind of seems like to me. And so, yeah, like it's a really good place to get started and just be creative. And the idea is not to create like anything like that's gonna, like, I don't know, change the world, but just gonna like, it's just gonna get your, familiar with right, the different SDKs, whether you do JavaScript or Rust, and like allow you to continue building on Near. And then you submit it and you're good to go. So here's like a bunch of resources. That like this is the pre-work slide deck, which is pretty robust. There's like a welcome track. The Near documentation, protocol specification are both like there's a lot of information there. And then there's office hours held every Monday and Friday from 11 to 12 p.m. that you can kind of go to if you have any questions regarding, like you have a bug in your code, or you have a question about the protocol or a specific implementation, you can get answers there. And then yeah, Jacob, my coworker, created this, which is really good resource of like kind of just general. I think it goes a little more in depth into what these slides were. Like, if you kind of want to reiterate or kind of review the information that was presented on this, I think this is a really good refresher of like the basics of blockchain development. Super, super helpful. I think that's it. So yeah, like I guess like what is your do you guys have experience with blockchain development, or where are you guys at in the journey?
Recently, I've been really delving into using Solidity, building out smart contracts that way. So like my question was, how do I kind of use that with Aurora? Because I've not been down that path yet.
Yeah, so it's really as simple with the Aurora stuff. It's because it's an EVM compatible chain. It's really as simple as, right, you can like upload the Aurora network in your MetaMask, or right, whatever you're using to deploy. It's just a different like endpoint. And then you can literally copy paste all the Solidity code.
Oh.
Yeah, all the libraries are there. Like all the popular ones are there. So that's what makes it. That was like one of the first initiatives. It's like we need compatibility with EVM type stuff, and a lot of people are working on more robust things. But yeah, for the most part, like yeah, like basically like right now, I still think even right now, even after the merge, there were just issues with speed and cost on Ethereum. So everyone was looking at alternatives, but like, okay, we have all of our smart contracts are on Solidity. What do we do? Okay, that's fine. Like, don't worry. It's like a copy paste, and you can get it over. So yeah, Aurora's really good. And yeah, they just came out with something like Aurora Plus, but like trying to give you basically like a white glove service for like your, using the protocol and developing your applications and stuff like that. So yeah, not too bad, but yeah, Solidity is a great place to start. I think yeah, I started with Solidity. It's like there's a lot of good documentation and stuff like that. Yeah.
What are you doing right now? You're on Rust.
Yeah, almost everything I do is Rust. Yeah. A little bit. I do like some of the work also is like trying to. I'm trying to push like Python. I think like that's like our next one that we really want to get on, because yeah, I come from more of a, yeah, Python was like my go-to programming language. Not pre, I don't know, like in call, I think like for interviews and everything, like Python's the best. Yeah. And it's a little more like, I feel like JavaScript developers, they might be more geared towards like front end and middleware stuff, where like your Python devs, well, now I was surprised. Yeah. You can have like full backends with Python, but like probably a little more geared towards the data science stuff and like the processing. So I think yeah, it would be good. I think just high level, like trying to really like, in the name of like making it simple and reducing barriers of entry, trying to get as many programming languages as we can on board, like natively as smart contract frameworks. Because yeah, the idea is like, yeah, it should be very usable, and like we don't need like Rust does have a learning curve to it.
Yeah. I think there's a lot of guys when they were here, they were going through everything plus. I'm like, I'm just trying to figure out the syntax. Like I don't even know.
Yeah. No, I remember when I was learning Rust, I was like, what is this? This is like very unusual syntax. But just like, I don't know, like any other programming language, I feel like if you have good fundamentals on like data structures and algorithms, and just like kind of like you understand, programming languages, yeah, like you'll be able to eventually figure it. It is like very unique though, but it has a bunch of really great properties that make smart contract development on it, like it's just very, very compatible with like blockchain, of how it, it uses memory super efficiently, and there's no garbage collector. It like it has this like automatic way of cleaning up your memory for you. And that kind of principle is like a really big value proposition. But at the same time, like, you know, yeah, like if the JavaScript or Python libraries, you know, get enough popularity, like, you know, what is your trade-off with efficiency going to be for ease of development? And like the JavaScript one really gets me excited. Like, okay, you could have your full stack in JavaScript, you know, like everything, you only have JavaScript developers on your team, and now you can just create like a full, you know, full stack blockchain application. And same thing that goes with Python. It's a little more like it would be very unusual to have like your full stack be in Rust if you have a consumer facing application. Like, no, you know, I don't even know if like you like a front end framework on Rust. Like I'm just not, you know, it wouldn't make sense. But like Rust, yeah, Rust is awesome. The more like I actually get familiar with it, I do like it. But yeah, I don't know. I guess that's it.
Are you gonna be at the hack